The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 6 for the Physics 2010 Midterm Exam 1. And this problem says that a stone is dropped from a cliff and is seen to hit the ground 3.0 seconds later. How high was the cliff? And so I'm going to work through this problem, and I'm going to be pulling equations from this formula sheet, which is given to you, or it's available to you. This is actually the formula sheet for this particular exam for this class. And I have a crude picture that illustrates basically what the problem statement is saying. And so we have this cliff, and we know that a stone is going to be dropped from some height down to the ground, and we know that the time it takes for this stone to reach the ground is 3 seconds. And we know that we're trying to find the height of the cliff, which is delta y. And I also define my coordinate system, which will have the x direction, positive x direction going this way, and the vertical y direction going up. So that means that our origin is here at 0. And so basically we know that if we can interpret something from the problem statement. We know that the stone is dropped, so it's dropped from rest. Even though it doesn't say explicitly that it's dropped from rest, we know that if we just drop a stone, it's not moving initially. So we know that the initial velocity is equal to 0. And we know that this is going to be a projectile because the stone, the only thing acting on the stone is gravity. Absent the, we can neglect air resistance. And so if we look at our formula sheet under projectile motion, we know that we want to try to find a formula that has delta y in it. And if we look under the y direction formulas, you'll see that we have a formula that says y is equal to the initial y plus your initial velocity times the sine of your initial angle times the time minus 1/2 times gravity times the time squared. And we don't really see delta y here, but if we rearrange this equation, so this is the equation that we want to use. And if we rearrange this equation and bring the initial y to the left side, you see that we'll have y, your final y minus your initial y, and we can recognize that as delta y because we know that delta y is y minus your y initial, so this can be replaced with just delta y, and everything else basically stays the same. So let's look at this part, right hand side of the equation. We know that the initial velocity is 0, okay? And we know that the sine, we need to find the theta sub 0. Theta sub 0, remember, is the angle that your object makes with the horizontal initially. So in that case, it would be basically this angle here. So that's essentially 3 pi over 2, or minus pi, however you want to look at it. We can say it's basically 90 degrees. Okay, so we can say minus pi and times the time minus 1/2 the time in this case is 3 seconds, minus 1/2 times our gravity, which is 9.8 meters per second squared, times 3.0 seconds squared. Okay? And that's just substituting in the numbers. This actually, the theta won't matter anyway, since we're multiplying 0 times that, so this whole term becomes 0. So we just get delta y is equal to, and when we multiply this out, we're going to get 44.1 meters. We get meters because we have a second squared. Both of those second squares cancel out. We're left with just meters. So we get delta y, and that's going to be actually negative, right? And that is actually correct because we defined our coordinate system where we have the origin here. So if we know that delta y has to equal to your initial, our initial is going to be 44, I'm sorry, it's your final, which is 0 minus 44.1 meters, that's negative 44. Okay, so the sign actually is consistent with how we defined our coordinate system. Obviously, the distance between the top of the cliff and the ground is 44.1 meters. Our sign is basically telling us what direction that the object is going, which is down. It's falling down. So the correct answer for this would be none of the above, because if we look at our possible answers, none of them equal to 44.1 meters. So we would choose none of the above. So this is none of the above.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.